Chapter 9 is sequences and series. Big ideas here have to do with variables, equivalence, and modeling. Essential questions and things to be thinking about as we go through these sections. How can we represent the terms of a sequence explicitly? And how can we represent them recursively? What are equivalent, explicit, and recursive definitions for an arithmetic sequence? And how can we model a geometric sequence? How can we model its sum? Section 9.2 is arithmetic sequences. I can define, identify, and apply arithmetic sequences. Big ideas here are, in these sequences, the difference between any two consecutive terms is always the same number. So the big thing there is difference, means the amount we add or subtract is always the same number. A sequence can be defined explicitly by describing its nth term with a formula using n, or recursively by stating its first term and a formula for the nth term using the n minus 1 term. What this means. Explicitly means we're going to have exactly one equation. We can find the exact value of any term as long as we know what number term. N here stands for the number of the term, as long as we use n. Recursively, we're going to repeatedly add together the numbers. So we're going to start with a number, we're going to add to it, 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 and eventually we can get to whatever number we want, the nth number. Okay, and we use the n minus 1 term. That just means the term before. So if we have the sixth term, n minus 1 is 6 minus 1, fifth term. So we take the number before and use that difference that we know about to find our value. In recursive, we repeatedly add. In explicit, we have exactly one equation. Here are equations here. This is our explicit. We have exactly one equation. The amount of any number term is our first term, the amount of our first term, plus we take n minus 1 times our common difference. So if we want the 12th term, we take 12 minus 1, so 11 times d is our common difference. That's our change every time, right here. The recursive formula, we have to repeatedly add on that common difference. So we have to say where we started, and then to find any value, we take the amount of the term before it, and then add on that common difference. So a couple things here. Our framework, and the things that will always stay the same in our common difference, is our a of n and our n minus 1. We'll plug in a value, our starting point, for a sub 1, and our common difference is d. That's our change every time. This difference up here. In our recursive formula, the things that always stay the same, a of 1 equals, and a of n equals a sub n minus 1. Our first term we put here, just like here, and our common difference we put here. So the number that we add or subtract every time is our d value. An arithmetic sequence is a sequence where the difference between consecutive terms is constant. So every single time, it's the same amount. So if we have 1, 3, 5, every time we add 2, for example. And that difference we call the common difference. The take note on page 572 talks about this. An arithmetic sequence with a starting value a and common difference d is a sequence of the form here. Okay, we have our first number, then our first number plus our difference, then our first number plus our difference, so we added 2. We add the difference again, so we have 3 of our common differences. And again, our formulas here. recursive definition, the parts that stay the same, we always have a sub 1 equals and a sub n equals a sub n minus 1. So the amount of term 1 is a, and the amount of any term equals the amount of the term before it, and minus 1 just means the term before, or the number before, plus the common difference. The explicit formula is a single formula. For the explicit definition and the explicit formula, we have exactly one formula that can find the exact value of any number we want right away. Things that stay the same, a sub n equals plus n minus 1 times, and then our common difference. So the only things that we plug in here, guys, are our values. Our initial value goes into our a sub 1 spots, and our common difference goes in the d spots. Example 1, we're going to figure out, is this sequence an arithmetic sequence? And in order for that to be true, it has to add or subtract the same value every single time. And we can use subtraction because that's just adding a negative. So we need to figure out what the difference is. From 3 to 6, we add 3. From 6 to 9, we add 3. 9 to 12, we add 3. And 12 to 15, we add 3. So since every one of these is the same, that means yes, arithmetic. And we could say that D equals 3, that common difference. For B here, from 1 to 4, we add 3. 4 to 9, add 5. 9 to 16, we add 7, and 16 to 25, we add 9. So if we look here, we can tell that there is a pattern every time we're adding 2 more than what we added before, but it's not the same number every time. So it is not arithmetic. Okay, because we did not add the same every time. They're not the same. Okay, let's try it. 2 to 4, we added 2. 4 to 8, we add 4. 8 to 16, we add 8. Okay, not the same every time. So it is not an arithmetic sequence or arithmetic. Either one works. 1 to 5 plus 4, 5 to 9 plus 4, 9 to 13 plus 4, 13 to 17 plus 4. Everything is the same here. Okay, the amount that we added every time is the same, so that means that it is an arithmetic sequence, and we can say that our common difference is 4. We want to find out what the 100th term of the arithmetic sequence is here, if it starts with 6, then to 11, and so on. So it's an arithmetic sequence, which means we know that we're going to add the same number every single time. The number that we're going to add, from 6 to 11, we add 5. So 5 is going to be our common difference. We want to know the 100th term. So we have two options for formulas here. We can use the explicit formula or the recursive. And remember, with the recursive formula, we have to repeatedly add that common difference. And I don't want to sit here and add 5 100 times. So instead, I'm going to use the explicit formula, because in our explicit formula, we can find the exact value of any term right away. So remember, our framework here is a of n equals our first term plus n minus 1 times our common difference. We want the 100th term. We know our first term is 6. We keep the n minus 1, and our common difference is 5. We can plug in 100 for n, just like I did here. And the amount of the 100th term 100 minus 1 is 99 times 5. Add them together, and we get 501, which is way faster and easier than if we'd have added 5 100 times. Here we want to know what are the second and third terms of the arithmetic sequence. So again, we know that we're going to add the same number every time. We're going to add our d value. So from here to here, we're going to add our common difference. From here to here, we're going to add our common difference. From here to here, we're going to add our common difference. We don't know what that common difference is, but we do know that we start at 100. We add 3 of our common differences, and we end up at 82. Again, we start at 100, we take our common difference 3 times, and we end up at 82. So I can solve this to figure out what my d value is going to be. Subtract 100. 3d equals negative 18. Divide by 3. And d is going to equal negative 6. That's not what it's asking for, though. It's asking for what are the next terms. So we're going to use our recursive formula here. We're going to take 100, the term before, to get our, plus our common difference, to get our next term. So 100 plus negative 6 is 94. It's our second term. We're going to take our term, we're going to add our common difference, and we're going to get 88. That's our third term. And then just to check, I'm going to take 88 plus negative 6, my common difference, and that gets me to 82. So my answer seems right. 100, 94, 88, 82. Again, we found that by taking our common difference, and we can use our recursive formula. First term plus our common difference gives us our second term. Second term plus our common difference gives us our third term. Third term plus our common difference gives us our fourth term. Okay, again, we want the 46th term here. So first we need to come up with our explicit formula. 3 to 5 is plus 2. 5 to 7 is plus 2. So our common difference is going to be 2. Again, framework, a of n equals our first term plus n minus 1 times our common difference. We know our first term is 3, and our common difference is 2. So to find the 46th term, I plug 46 in for n. That's the number of the term that I'm looking for. Here I'm just simplifying. And I get the value of the 46th term to be 93. I want to find the second and third terms of this sequence. So I'm going to add my common difference here 3 times. I'm going to start at 80, add 3 of my common differences, and end up at 125. So to solve for d, subtract 80, divide by 3. And I get my common difference to be 15. I'm going to start off with 80. I'm going to add this common difference. Get 95. That gives me my next term. I take that term and I add my common difference. To get my next term, I'm going to check my fourth term just to make sure. 110 plus 15 equals 125. So 95 and 110 are what I'm looking for. I'm going to stop this here and start on the next.